Okay, so the question is like this. From a point 36 meters above the surface of the lake, the angle of elevation of the bird is observed to be 30 degrees, and the angle of depression of the image in the water of the lake is observed to be 60 degrees. Find the actual height of the bird above the surface of the lake. So let us first try to draw and visualize what is actually happening in this question. Let us assume that this is the ground, this is the level of the lake, and then 36 meters above it, let us assume that there is some tower 36 meters high, okay, just beside the lake. So maybe this becomes your lake. Okay, some lake is this. Okay, and what is happening now? A bird is observed to be at 30 degrees of elevation, right? So let us consider that this is where the bird is. Let us call this B. Okay, so now the angle of elevation is 30 degrees, which means that if some observer is standing here, let us call this O, then this OB makes an angle 30 degree with the horizontal. This is the meaning of angle of elevation, right? So this is 30 degrees. Consider this to be horizontal line, imaginary horizontal line, right? And further the data is given that the angle of depression is 60 degrees for the image of the bird in the lake, right? So if the image is somewhere here, so image should be at an equal distance from the surface of the lake as is the bird, right? Let us call this B dash, as it is the image of B in the lake. Okay, and let us call this point as A. Okay, so now what is given? The angle of depression is 60 degrees, right? So this, if you join O and B dash, then the angle with the horizontal is equal to 60 degrees. This is the data which is given to you. Find the actual height of the bird above the surface of the lake, which means that we have to find AB, right? So let us assume that this length AB is equal to H height, correct? But if AB is equal to H, AB dash is also equal to H. Object and image are equal distance from the mirror. In this case, surface of the lake is acting as the mirror, right? So now we have completed everything that we can mark in this particular figure, right? Let us try to write few equations now. If you can see this triangle, let us also name this O. Let us call this C. In triangle OCB, I want to write tan of 30 degrees. To write that, I will have to know what is the perpendicular and what is the base. Base is OC, right? Perpendicular, I can write this height of the observer is 36 meters, right? So if this is OD, this is 36 meters above the ground, right? Which means that AC is also 36 meters. This will give me BC, which is actually the perpendicular for triangle OCB, right? BC is equal to H minus 36. Okay, now the base, let us keep base as OC itself, right? Because I have a feeling that it will not matter, it will get cancelled out. Okay, so in this triangle OCB, I have written tan 30, which is perpendicular upon base, it is H minus 36 divided by OC. Now move to the triangle OCB dash. In triangle OCB dash, I can write tan of 60 degrees. Tan of 60 degrees is again perpendicular. Perpendicular is how much? Perpendicular is this time H plus 36. H plus 36, and division is with what? The base. Base is again what? OC, right? So if I have these two equations, how can I find the value of H? H is what we need to know, actual height of the bird above the surface of the lake. So again, what we can do, we can divide the two equations. If we divide the two equations, the best part is OC will get cancelled out on the RHS, which is not required, and we will get one equation, single equation with only one variable h, right, which can be further solved. So let us do that. Let us divide equation 1 with equation 2, right? If you do this, what will happen? You will get tan 30 upon tan 60. So tan 30 is 1 by root 3 and tan 60 is root 3. So if you divide these two equations, you should get 1 by 3 in the LHS, right? What happens in RHS? In RHS, you get h minus 36 divided by h plus 36. OC in numerator and denominator gets cancelled, right? So let us just cross multiply and try to simplify this equation, right? So this will give you h plus 36 is equal to 3h minus 3 into 36, whatever this is, right? If you further simplify, let us take h on the RHS and the constant on the LHS. So we will have how many 36? 4 into 36, okay, and resultant values of h will be 2h, correct? So this time the value of h is coming out to be how much? 36 into 4 divided by 2, which is 72 meters. This is your final answer.